Hello children. Today we'll discuss about the types of sets. Okay, types of sets. Different types of sets. Let us start with empty set. Okay, empty set. A set. A set having no elements. Set having no elements is called as an empty set, or it is also called as null set, or it is also called as void set. Okay, it is denoted by phi. Okay, denoted by phi, or just only the chain brackets. Okay, in roster form. Now, any set we will define uh, in set builder form. Okay, any set can be defined in set builder form. For this, how to define? Now, phi or this one is equal to, you will write x. Okay, since there is no element, you can write x such that x not equal to x. See, x not equal to x, it is impossible. There is no such element that the element cannot be equal to itself. Hence, there is no possibility of this. So, you will not get any element. So, you get an empty set. Okay. For example, let us take one example. Okay. Set of set of all the months of a year having 32 days. Okay, so let the name of the set we have taken OY. Okay, now all the months of a year having 32 days. Now, how many months are there which are having 32 days? There is no such month. Okay, so either the months having 31 days or 30 days or 28 or 29 days in February. So, uh, 32 days, there is no such month. So, what you will write? You will write nothing. Okay, or you can write 5. And keep one thing in mind, some students, okay, they write this one as empty set because they consider that 0 is not an element. So sometimes we are saying no, nothing means 0. So you don't make that mistake. Okay, when 0 is written, it is also considered as an element. Okay, so this is not an empty, not an empty set. Okay, so any another example I can take now. In set builder form, let me take one example, that A is equal to x such that x square plus 4 is equal to 0. X is a real number. Okay, so let us find out this. X square plus 4 is equal to 0. This implies x square is equal to minus 4 and x is equal to square root of minus 4. Square root of minus 4. This is this square root of minus 4. This does not belong to R. This is not a real number. Okay, because square of any number cannot be negative. Okay, square of any number cannot be negative. in the set of real numbers. Some other number is there. Okay, we will discuss about that in the next chapter. That is called as an imaginary number. Okay, so as for this, okay, how it is given, x square plus 4 is equal to 0. X is a real number. So here by solving, you are not getting any real number, real value for x. So hence in roster form will be okay. So see, two things I have written here. X such that x not equal to x. This is the definition of empty set in set builder form. This is in set builder form, and this one roster form. Okay, empty set in roster form only chain bracket. Empty set is set builder form like this. Okay, so here this is given in set builder form, and in roster form it is an empty set. Okay, this is empty set. Next, next is finite set and infinite set. Finite and infinite set. Okay, so a set that contain countable elements is called as a finite set. Okay, a set that contains countable elements is called as a finite set. Otherwise, the set will be an infinite set. Okay, so the set contains finite number of elements, means countable elements. You can count the number of elements. Then you can say that yes, it is a finite set. For example, set of set of natural numbers. Okay, so set of natural numbers n you are writing like this: 1, 2, 3, 4, 5, dot dot dot. Because it goes to infinity. Here I have not given any condition, only set of natural numbers. So here you cannot count how many elements are there in this set. Hence, this is an example of infinite set. Okay. Then let it is given that A is a set x such that x square plus 3x plus 2 is equal to 0. Okay, x square plus 3x plus 2 is equal to 0. So let us convert it into roster form. X square plus 3x plus 2 is equal to 0. Here you will get x square plus 2x plus x. Split the middle term. Plus 2 is equal to 0. X common x plus 2 plus 1 common x plus 2 is equal to 0. So x plus 2 into x plus 1 is equal to 0. This implies x is equal to minus 2, minus 1, minus 2. So this is minus 1, minus 2. Okay. So it contains two elements. You can count it. So this is a finite set. Okay. A set that contains countable elements is called as finite set. If the set contains uncountable numbers, which you cannot count, then it is called as an infinite set. Okay. And one important thing, all the infinite set cannot be represented in roster form. Okay, all the infinite set cannot be uh, represented in roster form. Okay, you can represent infinite set in roster form. For example, here n, this can be represented in roster form, but not all the infinite set. There are some sets which cannot be written. For example, set of real numbers, that is R. Okay, R you cannot write in roster form. Why? Because R means the set of rational and irrational numbers. Okay, it is a set of rational and irrational numbers. So set of rational numbers you can write all the means natural numbers, integers. When you are writing the integers, it covers whole numbers, natural numbers, everything. Okay, but when coming over to irrational numbers, okay, there are so many rational numbers. Even in rational numbers also, uh, rational numbers, rational numbers, it is in the form of p by q, where p and q belongs to z integers, and q p q integers and q not equal to 0. So p by q it is not certain. You can take any integer. So you will get uh, so many rational numbers. So when it is the case of real numbers, only you know about the integers which is fixed. Okay, but when it is coming over to fractions, then you cannot list out all the fractions. Hence this cannot be written in roster form. Understood? Now equal sets. Third one is equal sets. Two or more sets having the same element having the same element are called as equal sets. Okay. For example, let us take a set A. Okay. Let us take a set A x such that x is a letter of the word okay A such that x is a letter of the word license. B another set. Okay, two different sets, but how they equal, I'm saying. X such that x is a letter of the word silence. Okay, so let us convert A into roster form. Let us write A in roster form. Okay, so it is the letter of the word license. Then it comes L I C E N LICEN, then S, then E. Already E is there, so no need to repeat it. So you are getting 6 elements in set A. Now set B. Okay, set B. The letters of the word silence. So S I L E N C and E already there, so I'm not repeating. Now you see here, this A contains 6 elements, B also contains 6 elements. L is there, I is there, C is there, E is there, N is there, and S is there. Okay, so all the elements which are there in A are there in B also. Okay, however, the order is different, but you know that the order is immaterial. Okay, so say it contains same elements. So in this case, you can say that A is equal to B. Okay, so A and B both are equal sets. Suppose A is given like this: 1, 2, 2, 3, 5, and B is equal to 5, 3, 1, 2. Okay, so though 2 is written 2 times, so it is considered 1 only. So 1, 2, 3, 5, 1, 2, 3, 5. Here also A is equal to B. If A is given 3, 5, 7, 9. Okay, B is given that B is given as 5, 7, 9, 3, 4. Okay, so these are not same. Here 4 is an extra element which is not there in A. In this case, you will write A not equal to B. Okay, so this is all about the types of sets. Okay, and based on this, I'll move forward to exercise 1.2. Okay, thank you.